And we're going to talk a little bit more about average rate of change. We talked about that a very little bit earlier on, but when you have 2 points on a curve, so I'm focusing on the curve here. And when you have 2 points on the curve, the line that connects those 2 points is called a secant line. S-E-C-A-N-T. And that does have something to do with like the secant, you know, the trig function secant. There's some connection there. I'm not going to get into what that connection is. So just you need to know that this kind of a line that connects 2 points on a curve is called a secant line. And then there's the average rate of change. Which is y2 minus y1 over x2 minus x1. But in calculus, sometimes we call that f of b minus f of a all over b minus a. It's the same formula. This is just a y minus a y and an x minus an x. Okay, so this is called the average rate of change. How does this slope, where is this slope in this picture? If I calculated the slope here, where is that represented in the picture? It's the slope of the secant line, right? Okay, so the average rate of change, we learned that formula back a few days. But it's the slope of this line here. That's the geometric interpretation of it. Okay, so it's not the slope of the curve. The curve doesn't have a slope really yet, but it's the slope of the line. And what it is if you found the slope here and here and here and here and here and here, all those places in between, it would be the average slope between those 2 points on the curve. So that's why it's called the average rate of change. Because if somehow you could find the rate of change at all these locations on the curve, see how that rate of change keeps changing, the slope keeps changing. If you could find the slope at all those places, the average of that would be this slope. So that's where the name average rate of change comes from. Okay, but average rate of change is easy to calculate. So that's if it's asked for average rate of change, you just find a point here, a point there, and then find the slope between them. So we've done that already. Okay, but what we really care about is, this is the new topic, what we really care about is what is the slope at that point there? So we're going to draw in a line that represents how steep this curve is there, just so we can visualize how steep it is. So this curve is pretty steep there. So this line here, this dotted line, is going to represent how steep the curve is at that one location. And that line is called a tangent line. Okay, so I drew that dotted line in to represent how steep the curve is at the point. And then I'm calling that dotted line the tangent line. So since the dotted line represents how steep the curve is, the slope of that tangent line is the slope of the curve. Or in other words, it's how steep the curve is there. So at a different point, like over here, there's a different slope. And so we draw a different tangent line to represent the slope at that location. No, the purpose of the tangent line is just to visually represent how steep the curve is there. So we can kind of see how steep it is. Clearly, there's a different steepness here than there is here, right? First of all, it's a lot steeper there. And second of all, it's a positive slope as opposed to a negative slope. So the slope of the curve changes depending on where you are on the curve. Let me say that again. The slope of the curve changes depending on where you are on the curve. Okay, so if you're skiing here, you're not scared, right? Because it's pretty easy. But if you're skiing here, well, that's a different story. So the slope of the curve changes. Okay, so our goal for today is to find out how steep it is there, to find the slope of the curve there. And this is not that big a deal. It doesn't come up that often. I'm joking. It comes up all the time. So this is a big deal. It's basically all of the first half of calculus is about this. So don't mean to scare you, but okay. So let's say we have an f of x equals x squared minus 4x, and we're going to find the slope of the curve at x equals 1. F of x equals x squared minus 4x. And we're going to find the slope of the curve at x equals 1. And we're going to do this a couple of different ways. So this is method 1. So just so I can get an idea of what's going on, I'm going to plug 1 into this function. 1 squared is 1. 4 times 1 is 4. And 1 minus 4 is negative 3. So we know that on this curve we have the point 1, negative 3. And we also know that it's a parabola. And since the x squared is positive, we know it's a parabola pointing up. So probably looks something like this. So it goes through the point 1, negative 3, and it's a parabola pointing up. Okay, and the task that I've been asked to do is right here is the point that I care about, x equals 1. And I'm trying to find out how steep it is there. So I'm going to draw in the tangent line. And that tangent line will represent the steepness of the curve at that point. So is my final answer going to be positive or negative? It's going to be negative, right? Because this tangent line that I drew in is sloping downward. Okay, now here's the problem. I have a point, 1, negative 3. But to calculate slope, I need 2 points. Because the slope formula is y2 minus y1 over x2 minus x1, right? And I don't know another point on this line. I mean, I could guess based on my sketch, but I don't want to guess. I want to get the actual slope of this line. So because I don't have another point on this line, I'm going to temporarily cheat, and I'm going to pick a point on this curve. All right, so I'm going to use this point, 0, 0. And I'm going to calculate the slope between those points. Now that's kind of crazy because it's not the right answer, correct? I'm looking for the slope of this line, and I'm going to find the slope of this line instead. Bear with me. I'll get to where I'm going in the right direction. Okay, so I'm going to find the slope between 0, 0 and 1, negative 3. Okay, so that's going to be 0 minus negative 3 all over 0 minus 1. Since it was Monday, I got temporarily confused, right? So let me write these points down for a second. I'm just taking y2, or y2 minus y1 over x2 minus x1. Just finding the slope between those 2 points. Okay, so that comes out to 3. Okay. Yes, it should be. Let's see. 0 minus 1 is -1. Thank you. And then 3 divided by -1 is -3. Good. Everybody good now? Thanks, Amy. Okay, so the slope of this line is -3. What is that? What line is that the slope of? Slope of the secant line, right? And what's the name for the slope of the secant line? The average rate of change, right? So we just figured out the average rate of change between those 2 points. That's not what we want. We want the actual rate of change at that point. So that's -3 is the wrong answer. But I had to use this point because I didn't know what other point to use. For slope, I need 2 points. Okay, so now I'm going to find this point on the curve. The x equals 1/2 point. Okay, so I'm going to take f of 1/2. That's 1/2 squared minus 4 times 1/2. So I'm just plugging 1/2 in to my function to find another point on this curve. So that's 1/4 minus 2, which is negative 1.75. So this point right here on the curve is 1/2 comma negative 1.75. Okay, now instead of finding the slope between these 2 points, I'm going to find the slope between these 2 points. Will that be the answer I'm looking for? No, it still won't be the answer I'm looking for, correct? However, this wrong answer was really wrong, and this wrong answer is going to be less wrong. I know my picture is tiny here. Does everybody see that? This wrong answer is really wrong. This wrong answer that I'm about to get is less wrong. Make sense? This is really bad, but then this isn't quite as bad. All right, so now I'm going to calculate the slope between this point and that point. And I'm still going to have a wrong answer, but it's going to be a better wrong answer. All right, so that's negative 1.75 minus -3 over 1/2 minus 1. So let's see. The bottom is -1/2. I got it right this time. It's negative. Then the top is 1.25, I think. So then dividing that, it's 2.5 negative. I think I got that down here. Yeah, that's what I got another year or two. So unless that and that is wrong, I think I'm okay. Okay, so this is still not the right answer, but it's better. It's a better wrong answer. So let me show you what we're doing so far. What we're doing is we are making a table of an interval and the average rate of change. So the first interval we went on was 0 to 1. And the average rate of change from 0 to 1, I calculated it right here, that was -3. Okay, then the next interval was a half to 1. I went between these 2 points. And I calculated that average rate of change, and I got negative 2.5. Okay, and notice that the negative 3 was wrong. It wasn't the slope of this line, right? The negative 3 was wrong, and the negative 2.5 was wrong as well, but it was less wrong. Okay, so what should I do to get an even less wrong answer? Yes. Make the interval even smaller, right? Now this is, you're never going to be able to see this, but let's say I went 0.9 to 1. Then that slope would be bad, that slope would be better but still bad, and this one would be bad but pretty darn close to the right answer, right? Okay, so my next interval is going to be 0.9 to 1. So I'm going to get a third wrong answer, but it's going to be the best of the 3 because my slope is toggling towards the right answer. Okay, so I need the point that occurs at 0.9 comma whatever. So I need to plug 0.9 into my function to get the y value. So that's, I did that last year or another year, who knows what year. Negative 2.79 is what that y value is. So where did I get this negative 2.79? Plug 0.9 into the function, right? Because the function spits out the y values on the curve. Okay, now I'm going to calculate the slope between that point and 1, negative 3. So that's negative 2.79 minus negative 3 all over 0.9 minus 1. And that comes out to negative 2.1. So now I can enter my third entry in my table here, negative 2.1. So this is a wrong answer, that's a wrong answer but better. This is a wrong answer but even better. So how could I get even better? 0.99 to 1, right? I'm not going to take the time to do that. What do you think these are getting close to? Negative 2. What does that sound like? A limit, right? Okay, so we're going to guess, based on this table, that the slope of that curve, aka the slope of that tangent line, is negative 2. It's a guess, because we don't know if maybe this is getting close to negative 2.05. But we're going to guess negative 2. Okay, so based on the table, we guess that the slope at 1 is negative 2. And just to throw some terminology in there, these were all called average rate of changes, right? Because they were the slope of secant lines. This is called an instantaneous rate of change. So that's called an instantaneous rate of change, rather than an average rate of change. Colin is my shelf blocking this word. Okay, good. So in there you can see. Cool. All right. So we're talking about average rate of change and instantaneous rate of change. Okay, so that was a table method, but now I'm going to do a different method. This is method 2. Okay, so for my method 1, what I did was, notice what happened in all of these slope calculations. The negative 3 didn't change, right? And the 1 didn't change. I was always minusing 1 on the bottom. And I was always minusing negative 3 on top. Why was I always using 1 and negative 3? Because that was the point that I cared about, right? That was the accurate point. That was the point on the curve where I was trying to find the slope, the point 1, negative 3. Okay, so I always used 1 and negative 3. A fancy name for negative 3 is f of 1, right? F of 1 means the output when you plug 1 into the function, aka it means the y value at 1. So f of 1 is just a fancy way of saying the y value at 1, which is negative 3. So that doesn't change. That was constant every time. 1, negative 3. 1, negative 3. 1, negative 3. That happened in all 3 of my calculations. But this other point did change, right? So I'm just going to put an x there to represent that that other point changed. So the first time x was a half. The second time x was, the first time x was 0. The second time it was a half. And then the third time it was 0.9. And then up here, I used the y value at that x, right? So a fancy way to say that is f of x. Okay, so this right here is the average rate of change. Okay, what did I do with this other x? I went 0, a half, 0.9. What's another way to say that? I picked x's that were getting closer to 1, right? 0, a half, 0.9, and then I suggested 0.99, but I didn't want to bother with that one. Those x's are getting closer and closer to 1. So I need to pick x's that get closer and closer to 1. And then I kept calculating this, right? And then I looked and saw what those were getting close to. That's what that means. LIM means look and see what they're getting close to. Okay, so this right here is the average rate of change. And then if I take the limit of it, it gives me the instantaneous rate of change. Because in my table, what those are getting close to, the answer to the limit is the instantaneous rate of change. So this is just fancy new calculus notation for what we did over here. It's not brand new because you've seen limits before, but it's a different way of saying this, and then that, and then that. Okay, now before I go on here, I need to make sure that you understand that before today, we were always calculating the limit of f of x, right? The limit of the y values. And you do this when you're trying to figure out if a function is continuous. You do this when you're trying to figure out if there's a vertical asymptote or a horizontal asymptote. You take the limit of f of x. Today, it's a new limit. It's not the limit of f of x. It's the limit of this whole mess. The limit of the slope formula, not the limit of the y value formula. So they're both limits, but they're limits of different things. Before today, we always took the limit of the y value. Now today, we're taking the limit of the average rate of change. It's a big switch. We're still going to do this sometimes. Then we're still going to do this sometimes, and you're going to get them mixed up. That's why I'm pausing there to point it out. Okay, now going on from here, don't I have a formula for f of x? Isn't that x squared minus 4x? So far from this step to that step, I just replaced f of x with x squared minus 4x. But that's the formula for f of x. And then f of 1 is negative 3. Because that's the y value at 1. Okay, so now I'm going to calculate the limit as x goes to 1 of x squared minus 4x plus 3 all over x minus 1. Should I try limit laws on this limit? Why not? The bottom's going to come out to 0, right? I could try limit laws, but they don't work because the bottom will come out to 0. So that means that the limit doesn't exist, right? No, it means that I have to try something else. What else can I try? Factoring, rationalizing, clearing double fractions, sandwich theorem. There's a whole big list of them, right? Factoring is the way to go on this one, because the top factors into x minus 1 times x minus 3. That works because negative 1 times negative 3 is positive 3, right? And negative 1 plus negative 3 is negative 4. Okay, then the x minus 1's cross out. And then limit laws will work. What's the limit of 3? What's the limit of x as x goes to 1? Check that out. Our guess last time was right. Yes? That's not necessarily true. If x was going to 7 here, then limit laws would work. So aren't you amazed that we got the right guess last time? I mean, I knew what the answer was, but you all saw it was getting close to there. Anyway, it's getting close to negative 2. That means the slope of the curve at that point is negative 2. So we calculated the slope of the curve at a point. That's the purpose of today's lesson, figuring out how steep the curve is. Yes, Lauren?
So, if you have a question like this, it wouldn't be enough to just do
No. If you have a question like this that doesn't have any extra directions, you can use either method, yeah. Now, as we go on and get more sophisticated, then we'll expect. But for now, both methods totally fine. Either one. Yep. Yeah, what Lauren's basically saying is, hey, if I do a homework problem like this tonight, do I have to do it both ways? And the answer is no. You can pick your method for now, unless the directions say do it a specific way. All right. Okay, so that was the slope of the curve at a point. So that was part A of this question. Find the slope of the curve at x equals 1, and I did part A using two methods, method 1 and method 2. So now I'm ready for part B, which is find the equation of the tangent line. At x equals 1. Okay, so instead of finding the slope of this line, which is what I did in part A, now part B is asking for the equation of this line. Okay, what is the equation of a line? How do you do that? Yeah. Y equals mx plus b is one option, right? What's another option? There's something called point slope form, right? Y minus y1 equals m times x minus x1. So whenever you write the equation of a line, you can use this method, point slope method, or this method, slope intercept method. Doesn't matter. You're going to get the same answer either way. It's just different ways of starting. Okay, so raise your hand if you like this one better. Okay, raise your hand if you like this one better. Okay, we'll do it this way, because that's what people are less comfortable with. So I want to help you out. Okay, so, no, I do actually want to help you out. I'm not joking. But I feel bad that I'm doing it the way you're less comfortable on a Monday morning. But anyway, so we're going to start out doing it this way. Then we'll go back and we'll do it this way. Okay, so y minus y1 equals m times x minus x1. If you're going to write the equation of a line, you have to fill in the slope of the line, right? In this problem, what is the slope of the line? -2. That's what we calculated in part A, right? Okay, so where the m is, I'm going to put a -2. So I got y minus blank equals -2 times x minus blank. Okay, then in these blanks, you put the point that the line goes through. So it goes through 1, -3, right? So 1, -3. And then, if this is a free response question, you can leave that as your final answer. You don't have to simplify it. Now, if it's a multiple choice question, maybe this isn't one of the choices and you got to do some algebra to manipulate it to the other form that the choice is. But again, if it's a free response question, just go ahead and stop here. Okay, just in case it's a multiple choice question, I'm going to go on. And then subtract 3 to the other side. Okay, so that was finding the slope, the equation of the tangent line using the y minus y1 equals m times x minus x1. Okay, now for the rest of you who are more comfortable with y equals mx plus b, let's do this again. So this is method 2 for part B. Okay, so I know the slope is -2, right? So that goes in for the b, or sorry, for the m. And then you know that this line, if it's going to go through the point 1, -3, when you plug a 1 in for x, the equation better spit out -3, right? Otherwise, it's not going to be going through the point 1, -3. So then I can find out what the b is. We already knew that, right, because of this. That's just the other way to do it. Doesn't matter which way you do it. Point slope form, slope intercept form. Either way, you're getting an equation of the line. Okay, there's also something called the normal line. Oops, I don't want to erase that. Okay, so at that point right there, there's a line that is perpendicular to the tangent line. So this line that I'm drawing here makes a 90-degree angle with the tangent line, and that's called the normal line. So the normal line is a line that is perpendicular to the tangent line at the point of tangency. In other words, at that same point. Okay, so for part C, we're going to find an equation of the normal line at x equals 1. Okay, so for the normal line, well, for the tangent line, the slope was -2, right? If it's going to be perpendicular, it has to have the opposite reciprocal slope. So -2 is -2/1. So if I flip that, that flips to 1/2, right? And then it's got to be opposite. So since -2 was negative, the other one has to be positive. So the opposite reciprocal, meaning it's flipped and negative or opposited, is 1/2, right? So that's the slope of the normal line, because it's the opposite reciprocal of the slope of the tangent line. Okay, so then the equation is put 1/2 in for the slope, right? And then what point does it go through? Same point as the other line did, right? The 1, -3. So there's the equation of the normal line. Again, if it's free response, just stop there. You don't have to distribute out the 1/2. Or if you do y equals mx plus b, that's fine too. I'm just doing the one you're less comfortable with, so you maybe get more comfortable with it. But it doesn't matter on the whole thing. Don't have to do it both ways. Okay. Okay, so what was the main topic for today? The slope of what? The slope of a curve at a point, right? And that's difficult because when you're on a curve, the slope keeps changing, right? So that's why we have to talk about the slope at the point. We can't just talk about the slope of the curve. You could talk about the slope of a line because it never changes. But you can't talk about the slope of a curve because it changes everywhere. So that's why you have to talk about the slope of a curve at a point. And in order to find the slope of a curve at a point, what you do is you take a limit. but it's a special limit. It's the limit of the slope, the y minus y over x minus x, right? It's not the limit of f of x. It's the limit of f of x minus something over x minus something. So that's how you find the slope of a curve at a point. Okay, so let's say on a different problem, you did all of that, and you ended up with this limit. I think I'm only on number 2 here. So this kind of looks like f of x minus a number over x minus a number. So you can see where maybe this limit came from. So if you're going to try to calculate this limit, what do? Clear the double fractions, right? Here's how you clear the double fractions. You multiply by x minus 2 over x minus 2. So then x minus 2 times that is 5. And then 5 times x minus 2 is there. See how that distributed? The bottom, don't multiply it out, just leave it. Tempting to cancel this. It's not legal because of that minus sign. Sorry to go so fast. I'm running out of time. We've done limits like this. It's just one of the harder ones, so I wanted to help you out. So sorry I didn't have time to explain all that. But now at least you have another example down in your notes on how to calculate limits with double fractions, right? That's usually what happens. I panic and think I'm out of time and rush too much. Sorry to panic on you. Thanks for listening today.